Have you ever gone down a slip and slide? Have you ever wondered what exactly makes it so easy to slide down the slippery slope? Well, today we will be discussing the physics behind the slip.
Have you ever walked on ice and then on the sidewalk? Walking on pavement feels so secure and trustworthy, but once you step on ice, it is so difficult to judge your next step. What does it feel like? Why do you slip so much easier? Simply, friction is the resistance that one surface feels as it tries to slide across another surface it is touching. It can easily be seen on something that is slippery versus not. If you think about it, we live in a world dominated by friction everywhere. But there is more than just friction itself.
The force of friction is. The force of friction equals the coefficient of friction times the force normal. And today we're going to make sure that you understand what the coefficient of friction is. You can see if aluminum is in contact with mild steel, the coefficient of static friction is 0.61, and the coefficient of kinetic friction is 0.47. If glass is in contact with nickel, the coefficient of static friction is 0.78 and the coefficient of kinetic friction is 0.56. You can find all sorts of tables for coefficients of friction between different materials. However, it is very important to understand the statement made at the top of the table I found at engineershandbook.com. Extreme care is needed in using friction coefficients, and additional independent references should be used. For any specific application, the ideal method of determining the coefficient of friction is by trials. In other words, coefficients of friction depend on the two specific surfaces which are contacting one another, and you should perform experiments to determine the coefficients of friction instead of relying on published values.
When you walk on the sidewalk, there is friction on the bottom of your shoes and the pavement preventing you from slipping. This would explain the law of inertia. The law of inertia states that, unless acted upon by an external force, an object at rest remains at rest, or if in motion, it continues to move in a straight line with constant speed. This is where Newton came up with the first law. It might seem confusing, because we are constantly living in a friction-filled world where things are always being stopped. However, if you are able to eliminate the friction, you will see the first law in action. Similarly, in the slip and slide, eliminating the first law of the tarp by adding soap and water helps show the physics behind the first law. Similar to ice skating, going down a slide with no friction stimulates the feeling of no friction. Friction slows whatever is moving on it down by introducing a force that opposes the direction of motion. In theory, the surface with friction will stop the moving object more quickly than the surface without friction.
Gravity is the force that pulls objects toward each other. This same force acts on Earth and keeps it in place. If there wasn't any gravity, things wouldn't stay on the same ground. On a flat surface, perpendicular to the sky, gravity is acting upon us, but cannot be seen. When we go down a hill, we get to see the force of gravity as it is pushing us down the hill. Kinetic energy is the energy as an object is moving at that instant. Potential energy is the energy that is building up prior to kinetic energy. When put on a sloped slide, the point of highest potential energy is at the top and lowest when in motion. Therefore, when in motion, kinetic energy is the highest. Kinetic and potential energy are always related with each other.
Let's say we take a ball that has 10 joules of potential energy, and then we simply drop it on a table. Now, it probably is not going to do that, but if it did, it would be a completely elastic collision. We converted that potential energy into kinetic energy, and as it bounced off the table, it returned all that kinetic energy back into the ball, so it was able to make it back again. Completely elastic. Now let's say we take another ball that's made of different material and drop it. It also has 10 joules of energy, but it doesn't bounce at all. We would call that a completely inelastic collision. Now where did that energy go? Where did those 10 joules of energy go? they became internal energy in the table and the ball itself that collided. And we know that most balls are going to be somewhere in the middle, somewhat elastic in their collisions. And so during any collision, which could be elastic or inelastic, we're going to maintain linear momentum. In other words, the momentum of the objects before the collision is going to equal the momentum of the objects after. In an elastic collision, not only do we maintain linear momentum, we also maintain kinetic energy. The speed before the collision equals the speed after the collision.
Newton's first law states that an object in motion stays in motion. However, there are a lot of things that happen when collisions occur. Physically, surfaces change and get distorted, but also the energy. Energy can transfer to other objects. For example, have you ever seen hockey players hit each other and one of them fly off? The energy is built up from the first player slamming into the second one and transferred by launching the second player over the ice. Similarly, on the slide, if one person is moving down with a velocity, while the other one is sitting there still, when they collide, one of them will lose their energy and transfer it. These transfers of energies can be generalized into inelastic and elastic collisions. An elastic collision occurs when the energy transfers to the second object and uses that energy to move. An inelastic collision is when the objects collide, maintain, and attach to each other, holding the same velocity.
The relative motion or frame of reference of an object is zero if it is with an object moving at the same velocity. To each other, they appear they aren't moving, but from a different perspective, they appear to be moving at the same speed. Just like with the sunglasses, Zach and the sunglasses are going down with the same velocity. Mass is a property of a physical body that demonstrates the resistance from force acting upon it. People with different weights have different mass and therefore different resistance. When someone with a greater mass collides with an object, their force applied is greater than the one that has a smaller mass. Anna and Zach have different masses, so their final output of momentum will be different. In addition, static friction force depends on the mass of the objects. The higher mass an object has, the higher force is needed to impede motion on it. Static friction force is directly proportional to the force we apply on the object, but reaches a maximum only to the product of mass of the object and the friction coefficient. Static friction, in simpler terms, is just the friction that is stopping the object from initially moving.